Hello everyone. Today we are going to see one of the important protocol, that is TCP, which lies in transport layer protocol. So the TCP is the important protocol of transport layer, and we also know that TCP is a connection oriented protocol. So we all discussed about this in a previous class also. So connection oriented means it will have a three phases. Okay, connection establishment, and after connection establishment data transfer, then after data transfer it will terminate the connection. Okay, so it will go through these three phases. Since it is a connection oriented, it must first establish a reliable connection before sending any data. And this connection, for establishing any connection, okay, there is a process called three-way handshake. Okay, so we will see about this three-way handshake process, right? Handshake process. So you might be thinking why we need this three-way handshake process. Because before two devices can exchange the data, both the side will agree to communicate. Okay, then synchronize the sequence number and confirm that both sender and receiver are ready. Okay, the three-way handshake ensure that both side can send and receive before data transfer begins. Okay, so that is why we need this three-way handshake in connection establishment phase. So we will see this three-way handshake process in detail right now. So in three-way handshake process, consider this is a client side, okay, and this is a server side, and client want to send a packet, okay, to the server, right? So consider this scenario, and packet means, consider, I'm not talking about packet. See, I may be interchanging the words. We are at transport layer right now, right? So in transport layer we are the data which I'm talking about, it's called segment. Okay, I even explained this before also. So data, okay, within this TCP header, okay, the data will be under the one cover, that is envelope, that is called TCP header, and this entire thing is called segment. So here we are calling it as a segment. So any data we refer at transport layer, we will refer it as a segment. Now, before understanding how TCP works, how this connection establishment, everything works, let's look at the TCP segment itself. Okay, so you know that segment itself contains a header, right? TCP header, and this header has some information, right? So that it can route this data to route to, so that this data can route to the particular destination. So we know there are some information, so we will look into that information field one by one, and we are going to make use of a few of the information field, that TCP header field, okay, so that this particular three-way handshake process can be implemented, right? So we are going to see that part. Okay, so we can see that this is a TCP header format, right? So this is a data which I am talking about, and this is a header, okay, and this together becomes a TCP segment, right? So all this thing, now inside, I told you, inside a header there is a information. So inside a header, this is the information, okay, and this information is necessary so that our data can reach to the particular destination what we know. Now we had already seen this particular field which is called source port number, right, and destination port number, and the bit required is 16 bit, and here 16 bit for source and destination port. With 16 we got 2 raised to power 16 minus 1 port numbers. If you start port number from 0 to 2 raised to power 16 minus 1. So all this thing we had seen. Now we can see one more field, that is sequence number field. Can you see that? And sequence number field, the bit is 32 bits. Okay, so with 32 bits, if you start from 0, with 32 bits, how many sequence number is possible? 2 raised to power 32 minus 1. Okay, this much sequence number is possible total. Now acknowledgement number is there. Okay, then this is called flag. Okay, flag is a 1 bit number, 1 bit field. Okay, either 0 can be there, either 0 or 1. Okay, so that is called flag. The flag is a 1 bit field, right? So you might seen this thing in C program also, that flag, if you set it 0, or either you set it 1, right? and there is something called window size. So we are going to see why we are going to use this all particular field. Okay, so now for three-way handshake, we will make use of all this field like source port, destination port, sequence number, acknowledgement, flags, window size. Okay, so whatever this sequence number, if whatever this field is required, all this we will make use of it while we are implementing three-way handshake process, right? So I was talking about the TCP header. In this, there is few things like I have already mentioned about source port, destination, sequence number, and all this thing, right? Acknowledgement. There are, I told you there are some flags, right? So this part is flag. Okay, and you can see here in this picture, you can clearly see what are the flags: URG flag, acknowledgement flag, okay, PSH push, RST, sync, okay, Fing flag. Okay, so we are going to make use of this Fing flag, Sync flag, okay, ACK flag. So all this thing we are going to make use of it while we are going to implement three-way handshake process. Okay, so we will see one by one. You just try to remember this part, right, or try to write it down. Okay, so all this field we are going to see one by one while we are making use of three-way handshake process. Now coming back to this scenario where client want to send a packet, I mean segment, to a server, and this client is some one kind of process, right? And this process might be running inside some computer. Okay, then that computer might have some IP address. Okay, so that IP address I'm considering as IC. Okay, and the server also uh, some kind of process, and it might be running inside some computer. So that IP address I'm calling it as, for that computer IP address I'm calling it as IS, and it is a process, right? So it definitely have some port number, and that number I'm calling it as X, right? And at server side I told you have to select a well-known port number. Okay, and at client side this port number, this is selected by your operating system, randomly selected by your operating system. And at a server side the port number is a well-known port number. Okay, and all this port number is selected from what range? You can see at the TCP header. At TCP header, see the port number, it is 16 bits port. So from the range 0 to 2 raised to power 16 minus 1, from this range the port number will be selected by the operating system randomly. Okay, so all this thing we know also in previous classes. So now we will start our connection establishment phase. In that we are going to see the three-way handshake process, how it's going to work. Now in this three-way handshake process, at the beginning what will happen, client will generate a dummy packet. Okay, it will create one dummy packet. It will be hardly of 1 byte, right? And I told you for every byte at TCP there would be some sequence number associated with it. Okay, right? So now the question is, what would be the sequence number? Okay, now this sequence number will be randomly generated by the operating system for this client, for this particular dummy segment. Okay, it will be randomly generated sequence number. Remember this point, it will be randomly generated sequence number. Okay, so now consider this initial randomly generated sequence number will be, for example, considered to be 101. Okay, so this particular packet will get 101 as a sequence number, right? See, remember this, whatever I'm talking, this is not an actual packet. Okay, it's just a dummy packet which you consider 1 byte, and for that there would be some sequence number. I told you for every data, for every byte there would be some sequence number, right? And that sequence number is randomly generated, okay, by the operating system. So this is called initially generated randomly initial sequence number. Okay, So there is one name for this randomly generated sequence number, which is called RISN, that is random initial sequence number, because it is the first sequence number which is generated for the first byte, right? So its name is RISN, random initial sequence number. Fine. Now I told you that so as we imagine, a client wants to connect to a server, okay, and for that it's sending a dummy segment, right? And that dummy segment is of 1 byte, and for that it got a sequence number which is randomly generated. Now that dummy segment, anyway, it is a data only, right? So that would be see the data, it's a imaginary data, right? And there would be some header, right? And I told you that this header contains some routing information, means some information, so that your particular data or this segment can reach to that particular server. Okay, that information also we see, that information, this is the information it contains. Now what we are going to focus is, see, look at this flag. I told you, this is a flag part. So at this you can see this SYN sync flag, right? So it is a 1 bit flag, and it will contain at least either 0 or 1. So when a client is sending a packet, means I mean this data, this particular sync segment, so at that time whatever the TCP header contains, that information, that particular information I am writing at this propagation. Okay, while it propagating, whatever the information TCP header contains, that I am writing here. Okay, so let's see what are the information. So at the beginning, in the header information, client will send this sync flag as 1. Okay, so sync flag as 1, I mean this particular thing. Okay, this particular sync flag will be set as 1 by the client, right? What does it mean by it? What does it mean is that client is telling that I want to, means a client is telling to a server that I want to start a connection, right? For that it's setting it as 1. Okay, so like this you can understand. Now what is the next information that header will contain is sequence number. Can you see? Sequence number. So in this field it will write the sequence number, whatever the randomly generated sequence number, that it will be written. So it will write sequence number as, what is the sequence number? It will write 101, right, in that sequence number field. So by writing all this thing, what does the client convey message to a server? It is telling that, hello server, I want to communicate with you, and for that I'm sending her some dummy packet, and this is the first packet I'm sending, this is the first segment I'm sending. Okay, that's why sing equal to 1. See, whenever sing equal to 1 means that means that would be the first segment you are sending. Okay, and that segment contains a sequence number 101. So all this message client is conveying to the server. So when this particular packet receives, na, server will understand all this particular message, right? Now the next message, now the next thing what a client will write is MSS. MSS to be 1460. Consider this. So what is the meaning of it? See, MSS means maximum segment size. Okay, maximum segment size. We can you can see here. I already mentioned it. Okay. So what does it mean? See, this means that client is telling to a server that a maximum segment I can receive is 1460. So it's telling to a server that if you want to send me a packet, okay, if you want me to send a segment, then the maximum segment that each packet should contain should be at most 1460. It should not be more than 1460. So if you want to send me a packet or segment, then the each segment should be at most 1460 size. Okay, if it is more than 1460 size, please don't send me a packet. That is what the message a client is telling to a server by mentioning this part, MSS equal to 1460. Okay, so when this packet reaches to server will understand, the client has a MSS equal to 1460, so I should not send any packet, okay, or any segment whose size is more than 1460. Okay, so each segment should be at most 1460. If it is more than that, it will not server will not send a packet segment to the client. Fine. Now you might be wondering that how server is sending a message to a client or something. As client is sending a message, how server is. See, you have to understand one thing. TCP is a half duplex. TCP uses a half duplex connection. Sorry, full duplex. TCP is a full duplex connection. Okay, so TCP is a full duplex connection. So what do you mean by that is that if a client is sending a packet, and meanwhile if sender is also want to send a packet, okay, then that is possible. Simultaneously both the parties can send a packet. So in that case there is no concept of client and server here. Okay, just for explanation, because all this thing will happen parallelly, simultaneously, so I can't. Just for explanation, I'm keeping this part left side as a client and right side as a server. Okay, if client is sending a packet, at that same time if server is sending a packet, then server will act like a client. Okay, and if that is received by client, then this particular client will act like a server simultaneously. So sometime client will act like a server, and meanwhile server can act like a client. So both the way is possible. So when client and server is sending a packet, so you might know when this is a client, so it might have some buffer, right, for for transmission purpose, and at the server side there would be some buffer to maintaining a flow control mechanism. Meanwhile, if this particular server is acting like a client, then at the client side it will have a buffer for transmission, and when the client is acting like a server, then at server side it will have one more buffer for flow control mechanism. So for totally, if you have a four buffers, then this flow control mechanism can be easily managed. I mean, this full duplex connection can be easily managed, right? So that is what I mean. So both the parties will have at least four buffer, okay, for this particular full duplex connection. Now there is one more field you can observe, that is sequence number. Can you see this? Window size. Can you see this part? Window size, and it is of 16 bits, right? So suppose client is mentioning his window size as 1400, 14, take it 14,600, okay, byte. So it is mentioning that my window size is 14,600 byte. So what does it mean? It means that client is telling to the server that it has a buffer reserved whose size is 14,600 byte. Fine. So with this MSS, with this information of MSS and WS, window size, what is the message we are conveying to a server? We are telling to a server that if you want to send me a packet, okay, client is telling to a server that if you want to send me a packet, then each packet, I mean segment, each segment should be at most 1660 byte, 1460 byte. Okay, it should not be more than that. And like this you can send up to 10 segments. Like this you can send up to 10 segments. How 10 segments? Okay, we will find it out. How 10 segments. Now how this 10 segment came, right? Now we know that at sender side there is some buffer, right? And we are already seeing that that buffer is window size, right? So window size says that the buffer size is of 14,600 byte, right? And MSS means segment size. So maximum segment size. So each segment is of 1,640 1460 bytes, right? Now if each segment is of this much size and the buffer is how much, then how many segment can be accommodated by this buffer? How can you calculate? It's very simple, right? It would be 1000 total. We have 1000, so each segment is of how much? 1460 bytes. So 1460 bytes, byte, this will be cancelled, and 460, 460. The total is 10. So 10 segment is possible. Can you write? Can you see that? So like this, 10 segment will be possible. Like this, 10 segment will be possible. Each of 1460 bytes. Okay, first, two, three, like this, 10 segment will be there. Okay, then that is the meaning of it. So with the window size, we understood that the buffer size is of 14,600 byte. Maximum segment, each segment is of 1460 bytes. So totally at the buffer, at the client side, there can be up to 10 segment it can store. Right. So this information we got it. So at when this packet arrived at server will understand that I can send each segment 14,660 bytes, and like this I will send up to 10 segments. So server will not send more than 10 segments. Fine, because buffer, otherwise buffer will be full, and if it's buffer with full, then definitely client will not accept it. Okay, it will discard those packet, right? So maintain that flow control mechanism. So this is what the information a server will understand when it receives the packet. You're looking at MSS and WS. Fine. Now this particular dummy packet will reach to a server. Okay, and at the server. Now at the server, what the server will understand looking at all this information, it will understand by looking at the scene flag. It will understand that this is the first packet which a client is sending, right? That first thing is set to 1, and the sequence number of that particular packet is 101, right? Looking at MSS, it will understand that client, the maximum segment, each segment contains what a client contains is 1460 bytes. Okay, and the size of the buffer at the client side is 14,600 bytes. So all this information a server will understand looking at this particular information which is got from the client. Okay, and that information is in the header of a dummy packet, dummy segment. Fine. See, you might be wondering where this MSS is, maximum segment size, right? See, this particular field is come under option. There is something called option. Okay. Okay, this MSS is stored inside this option. Okay, option field. So option field is used for storing the information of MSS. Fine. So this will be option. It comes under option field. Okay. Now when this dummy packet receives at server, okay, then server will also try to reply it back. See why we are sending this dummy packet? Because client wants to establish a connection, right? A client wants to start a connection with a server, right? Now if server is willing to accept that connection, then it will also reply back, right? It has to reply back. If it accept the connection, then as a reply it will also generate this dummy packet. It will also generate this dummy packet. I mean dummy segment, which is of hardly of 1 byte. Fine. And for that, there should be some sequence number, right? So there should be some random initial sequence number, right? And that sequence number, for example, considered as 3000. Fine. So at server side, it has generated one dummy packet. Now we know that this is the first time when server is sending one packet. So SYN flag, it will set a SYN flag as 1, because for server this is the first packet is sending, right? And for that, what is the sequence number? Sequence number also it will mention as 3000, which is randomly generated, right? And it will also give an information about the MSS, means what is the maximum segment possible, okay, at the server side. So for example, consider it as okay, it will be around, for example, take it 1000. Okay, so it is telling a server is telling to a client that each segment, okay, is of 1000 byte in my side. Okay, so if you want to send me a packet, server is telling to a client, if you want to send me a packet, then each segment should not be more than 1000 byte. Okay, so keep that thing in mind while sending a packet. That is what a message conveying to the client by a server. Fine. Now the next information what it will give is window size. So suppose window size is considered to be 20,000 byte. So what does it mean? That server is telling to a client that at my side the reserved buffer is of size 20,000 byte. Okay, so with 20,000, how much is a segment you can a client can send to a server? So I think it will be around 20,000 divided by 1,000. It will be around 20 segment, right? So client can send up to 20 segment and each of size 1,000 byte, right? So that is the information what a server is conveying to the client. Fine. Now at send server side, along with this information, it will contain few more information like acknowledgement number. Okay, acknowledgement number. And consider the acknowledgement number. What would be the acknowledgement number here? See, here the acknowledgement number will be 102. Okay, you might be wondering what does it mean, right? See, what does it mean is that, see, you can see sequence number is 101, right? So what the message a server convey to a client is that, yes, I received a packet whose sequence number is 101, right? Server is telling to a client that I received a packet with sequence number 101, and the next packet which you have to send me, its sequence number should be a 102. It should start with 102. Okay, so I already consumed your packet. Now you send me a next packet and its sequence number should be start with 102. Okay, so that is the message what a server convey to a client. Fine. So by looking at this, client will understand, I am going to send a packet and its sequence number should be 102. I should start with 102. That is the message it will get when it look at this acknowledgement number equal to 102. Fine. Now one more information it will send is ACK. ACK, there is something called ACK flag. It will set to 1. Okay, so what does it mean? That this flag ACK is a flag. So when it is set 1, that means this particular packet what you are sending, Okay, it contains an acknowledgement, and yes, it is right, it contains an acknowledgement, right? So when ACK flag is 1, the client will understand, yes, whatever the packet is received from the server, it contains an acknowledgement. That means the previous packet which is the client had sent to the server, it is already acknowledged. That's why it is setting all these particular parameters. So together with ACK acknowledgement number 102 and ACK equal to 1, what message does a client understand is that whatever the previous packet is, so what servers tell to the client is that whatever the packet client has sent, server had already acknowledged it. Okay, and it's telling to the client that the next packet what you have to send should contains a sequence number 102. That is the message what a server is conveying to the client, right? Using this field acknowledgement number and ACK flag, right? You might be wondering where this particular field is, right? So in TCP header you can see acknowledgement number which is of 32 bits, and ACK is here. See, this is a flag, and this is a 1-bit flag. Okay, so it will contain either 0 or 1. 0, if is ACK is set to be 0, that means there is no acknowledgement in the data what you are sending, right? Now when this packet received at a client side, then what client will do? Client will send a final acknowledgement packet. Okay, client will send a final acknowledgement segment. So for that it will send a packet, the final acknowledgement. So it will send, right, sequence number. What would be the sequence number? Sequence number should be 102. You can see at the acknowledgement number. So that should be the sequence number. See, here we are not going to use a sync flag equal to 1. Why we are not using a sync flag? Because this is a second data you are sending. Okay, second dummy data you are sending. Okay, whenever you are sending the first one, then only you have to send a sync equal to 1. See, at the client side, it is the first time it's sending a packet. That's why sync flag was 1. Okay, at the server side also, it is the first time it was sending the packet. That's why sync flag was 1. Okay, now at the client side, this is the second time it is sending. So it will not use a sync flag equal to 1. Okay, it will, okay, that will be set as 0 only. Okay, so you don't have to mention here. So sequence number equal to 102 means that particular dummy data contains 102 as a sequence number, right? Now the next information would be acknowledgement. So acknowledgement number will be what? What would be the acknowledgement number? So sequence number will be acknowledgement number will be sequence number from the server side. Okay, whatever the sequence number the server side plus 1. That means 3001. So what does it mean? This means that client is telling to the server that I had received your previous data, previous segment whose sequence number was 3000. Now if you want to send me a packet or segment, then its sequence number should start from 301. Okay, so I already acknowledged your segment. Now if you want to send me a segment, then your sequence number should start from 301. So acknowledgement number will always be a sequence number plus 1, right? ACK flag. Now the ACK flag will also be 1 here, right? What does it mean? This means this particular segment contains a acknowledgement. That is the meaning of it, right? Now by sending this last acknowledgement, okay, client confirms that both the side are ready to start the communication. Okay, so and by receiving this particular data at the server side, server understand that whatever the previous data it had sent, it is already acknowledged by the client. Okay, so what we understood is that at the beginning when the client is sending this particular data, okay, what it wants, that it wants to start a communication. Fine. It tells to the server that it wants to start a communication, and server, by sending this packet, it tells to the client that it it is willing to accept the connection. Okay, it is willing to accept the connection. And by sending this final acknowledgement by the client side, client says that we both are ready for communication. Okay, let's start sending a actual data. Okay, so that is what this three-way handshake process is. Fine. So this three-way handshake, so whatever we're talking about was three-way handshake process. Okay, so this process helps for establishing a connection between a client and server. And after this three-way handshake, we both will start sending a actual data. See, they were still sending the previous only a dummy segments. Okay, it was not an actual segment. This is just for connection establishment phase, right? Now there are few things we have to understand. That, see, I had written here, when sync flag equal to 1, whenever the sync flag is 1, then it will consume one sequence number. When acknowledgement is set to 1, acknowledgement flag is set to 1, then it will not consume any sequence number. When data byte is set, when data byte means when you're sending a actual data, okay, at that time also it will consume one sequence number. Fin flag is set, then also it will consume one sequence number. So what is the meaning of it? One sequence number consuming. What is the meaning of it? See, if you look at this part, sync equal to 1. Okay, it's set as sync flag is set 1 and your sequence number is 101. Right. Now next time when client is sending a packet, next time where it's sending here, when next time when client is sending a packet, at that time the sequence number, okay, at that time at that time client is sending a packet here, right? So at that time the sequence number will be 102. It will not use 101, okay, because the 101 is a sequence number is consumed. So next sequence number will be used. Okay, so you might be thinking this is a normal process, right? What is in that, right? So look at this particular field. I mentioned when acknowledgement flag equal to 1, then that 0 sequence number would be there. That means it will consume no sequence number. What is the meaning of it? See, look at this particular field, this particular segment. Here we can see acknowledgement is 1, right? Here also acknowledgement is 1, but there is a sync flag. Okay, but here there is no sync flag. Here there is no sync flag, but acknowledgement is 1, like this. And it's not consume any sequence number. What is the meaning of it? This is called pure acknowledgement. Okay, because this is not a data. See, if you're actually sending a data and there is one, then it will consume one sequence number. What is the meaning of it, right? So next time when you're sending a packet, okay, then you tell me what would be the sequence number. You might be thinking that sequence number should be 103, right? Because 102 is already 102 we already used, then 103 will is a sequence number for the next packet. No, the next, for the next packet also the sequence number will be 102. That is the meaning of this. That is the meaning of this part. The acknowledgement is 1. Whenever the acknowledgement is 1, then at time you can reuse that particular sequence number for the next packet. Okay, so what you actually meaning is that, see, there is no sync flag. If there is a sync flag, then it will consume one sequence number. If you are actually sending a data, then also it will consume one. See, in this case we are not actually sending any data. Okay, and acknowledgement is also 1. We are just sending a dummy packets. It's not an actual packet. This is what talks about is actual packet. And if there is something called film flag is 1, then also one sequence number is sent. So this part is called pure acknowledgement. What does it mean by pure acknowledgement? Pure acknowledgement is nothing. See, acknowledgement is of two types. Acknowledgement is of two types. That is pure acknowledgement and piggybacking acknowledgement. Okay, so in pure acknowledgement, we just send a header. Okay, along with the header, there would be a acknowledgement. Okay, we will not send a data. Okay, and in piggybacking acknowledgement, what it says, along with the data, we will send a, along with data means actual data. I'm not talking about that dummy data. See, here also there is a data, but it's a dummy data. It's not a some actual. So it's a negligible thing. So that's why I'm telling you it will send only a header. So along with the header, there would be acknowledgement. That is called pure acknowledgement. Okay, consider like this. But piggybacking acknowledgement means along with the data, you will send a an acknowledgement. So that is a piggybacking acknowledgement. So in this case, this is not a actual data you're sending. Okay, that means what does it mean? It's a pure acknowledgement. And moreover, there is ACK flag equal to 1 is also set. That means this part will be activated. So you can reuse that sequence number again. So in the next time when you're sending a data, you can reuse that sequence number for that particular packet. So that is the meaning of this particular part. So be careful in this kind of questions. Okay.